The title for this one, I would say permutation involving identical objects. So that's the one I would highlight, identicals. When some of the objects are identical, meaning you cannot tell them apart, there will be fewer permutations. Okay? We need to divide out any repetition. Note, identical objects would be such things as marbles, shirts, things that you cannot tell apart, letters. Okay? Arranging people wearing the same color t-shirt would count as unique. Okay, they're not identical. So sometimes they're like, hey, people have all wearing red shirts. They're like, oh, identical. So let's divide that out. It's like, no, people have different, right? Their faces are distinct. So don't fall for that. There's no repetition there. The formula for repetition is as follows, okay? I think you should have this formula on your study sheets. Where basically, I'm going to use different colors here. 3 different colors, in fact. So when you want to arrange something side by side, guys, side by side, okay, we're arranging for a picture, there will be what we call N is everything we have available to us, right? So let's say we have 8 letters in a word. You would go, it's easy. Just take the number of letters and go factorial after that, and then you're done. However, if you notice that the word has like several I's or several E's, you need to number of first set of identical objects, you need to make sure you go 8 factorial. So if there's 2 I's, you would go 2 factorial. You would want to divide that out. If there is another repeat, another set of identical objects, you would also want to go ahead and divide that out. And why is there a dot, dot, dot? Because for every set of identicals, you would want to divide them out for as many as you can find. Usually, I mean, actually one exam had a word that was probably 27 letters long. And there were like a bunch of I's, a bunch of O's, a bunch of S's, like they were like a bunch. So they actually tested if you understood that you had to keep dividing for as many repetitions as there were, okay? But usually I haven't seen more than 2. And I make a note here, right? The denominator will change depending on how many sets of identical objects are present. I think that's worth highlighting. Okay, so let's start with the first one. So now it's where you have to check every time. Every time I give you a word, you have to check for repetition. So how many ways can the letters in the word eyes be arranged? Okay, what's N here? 1, 2, 3, 4 letters. Yeah, go ahead. And then 2 E's, right? So A, in this case, would be 2 E's. My A in the formula, right? So the number of permutations would be 4 factorial divided by, there's 2 E's, right? So 2 factorial. So this represents the 2 E's. So 4 factorial is 24. 2 factorial is 2. So there's 12 unique permutations. And this is the reason, okay? Reason for dividing. Let's say you go eyes like this. And let's say we could put a little Sharpie mark on them so that to distinguish them. Let's go E sub 1 and E sub 2. Right? That's one permutation. What if I put this E up front and this one where the other one used to be. Like I just swap them. If I do this, we can tell them apart because we did something to it, right? But technically, this one and this one is the exact same permutation. You can't treat them differently, okay? So this one counts as one permutation. Permutation, Mr. Erickson, permutation is confusing. Arrangement. Okay, this is the reason why we divide when there's identicals, because we cannot tell them apart. So we can't just say 4 factorial, because when we just do 4 factorial, we're counting these as 2 separate arrangements. However, they are not. They're identical. So we divide it out. We divide out the repetition. Okay, so let's do another one. Cactus. N is 1, 2, 3, 4, 5, 6. And I'll just do this. 2 C's. Anything else that's repeating? This always plays tricks on my eyes. I don't know. 2 C's. That's it, right? So this would be 6 factorial divided by 2 factorial. So that's 720 divided by 2. That is equal to 360 unique arrangements. So we divided out where the C's would have been counted each as individual arrangements. We divided that out, so it's half as many because of that. Eyeballs. 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8, and then I go right next to it, there's 2 E's and 2 L's. So you used to be able to just say, Mr. Erickson, it's just 8 factorial, that's it, right? And I will say, well, it used to be, but times have changed. We have to divide out the 2 E's, and we have to divide out the 2 L's. So these are E's, and these are L's. What is that? That is 40,320. This is 2 times 2. So it's 40,320 over 4. So it's really just 10,080 ways. Before, a word that had 8 letters would just be 40,320 arrangements, but now, because there's repeats, it's actually just 10,000, okay? Because we are not counting them each individually as that, okay? I'm gonna ask you to try a few. Try the one on the on page 25 there, Canada. And I would say on your study sheet, have one of these examples. Maybe have eyeballs in your study sheet. Have one of these examples and tell yourself why you did that, okay? Why you divided. So let's go to 25. Try Canada. Just do the no restrictions first. Let me do the next 2 bullets there. Okay, Canada. N is equal to, N is equal to 6. There are 3 A's. So this would simply be 6 factorial divided by 3 factorial. 720 divided by 6, that's 120. And you might ask, Mr. Erickson, but you said no restrictions. What about this? That is not an option. We have to address it. So by no restriction means like you don't have to have a certain letter at the front or at the end or in the middle. There's no additional restriction other than that. Here's where it gets complicated, okay? I will always ask you to check for this moving forward, okay? Where is this? I will ask you to check for identicals further restrictions and also together. Those are the things that I will ask you to check moving forward. Are there any identicals? Are there any further restrictions? Do you need to like stay beside each other or together? Okay? So let's try this one together. The first letter is N, the last letter is C. N, C. No options there. How many are left? You've got 4, 3, 2, 1, which is really just, if you think about it, it's 1 times 4 factorial times 1. And that is really just 4 factorial, which is 24. And now you're thinking, wait a minute, so are they identical? So we did the restrictions, we took care of the restrictions, right? N and C having to be stuck there. However, do we still have to deal with the identicals? Yes, so I'm going to use a different color for that one. Where's my red pen when I need it? There we go. We're now going to say divided by the 3A's. Okay. So that's 24 divided by 6, which is just 4 ways. And think about it. Out of the 4 letters that remain, how many of those are A's? 3 of them are A's, right? So there's not a whole lot you can change in terms of the arrangements. If you lock in N and C, and this is left, so we gotta make sure you don't forget about this. So this is the restriction. How should I do this? I'll just do restriction. And this is identicals, okay? And I'm going to highlight that. Restriction, identicals, I got rid of that. There's nothing that we had to keep things beside each other, so we don't need to worry about that. What if the first letter is an A? What if the first letter is an A? How many A's are there? A, A, A. Do we need to consider all 3 cases in this case? Would they be different if we use this A or that A or that A? Would we say those are 3 distinct cases? And the answer is no. Because they're identical, you just say that you only have one option for the first letter. Okay? Now, how many are left? If you use 1, you are down. Remember this one tile? This would be 5, 4, 3, 2, 1. Let's pay attention to this part. This is the restriction. That's the restriction, right? Has to be at the very front. So could we say 5 factorial and be done with it? No. What else is happening? What else is still... if you use one of the A's, how many A's are left for this part right here? 2. 2 A's remain. So this would be 2 factorial. 2 A's remain. Okay? So this part right here is identicals. You can do this, guys. You just have to practice, okay? So what's 5 factorial? That's 120. 2 factorial is 2. 60 is my total. I'm mixing it all up. I know. You're probably not very happy with me right now. Stop doing that. Okay? Can I just tell you a little bit about this? If it said it has to start with an N or a C, this would be N comma C, right? You have 2 options because N is a case and C is a case. They're distinct. But because the restriction was the letter A, which I have 3 of, I'm not going to put a 3 here because every time I use one of the A's, it is exactly the same, right? I'm not going to treat it as 3 different cases. So that's why you had to put 1 there. So when the restriction happens to be a repeat, you still just put 1 in there, okay? Otherwise, you're counting it 3 times and it's not, okay? Okay, I'm going to stop here a little bit. I'm going to ask you to try 25 to 26. So this is what I'm going to say here. Page 25 to 26 now. Okay? And then I want you to also try 45 to 48. It looks like a lot, but most of these questions are actually done fairly quickly. Okay? I do want to go over at least this page before we leave. So try to get this going. If you're stuck on this one, maybe go over to page 26 and continue with the Mississippi. I think you should all be able to do Mississippi. And just give it a try. And I'm going to walk around, and if you're not sure, if your neighbor doesn't have the answer, maybe I'll have the answer. I'll help you out. But you need to practice. That's just it. And I don't expect you to ace it today. Use a pencil. Try working through this, okay? All right. 5. I'm just going to ask you this, okay? 45 to 48. Do that on your own time. So let's see here. So we've got balloons. They're different colors. He wonders how many possible combinations are possible. There's too many possibles there. When you tie them onto a string and hang them across the ceiling. So the balloons are kind of all like in a string, right? They're all next to each other like this. So they're arranged, right? So same colors. You have to think of identicals, right? You can't tell the balloons apart, really. Red ones. So it's almost like I want you to think of a word that has 5 B's, 5 G's, 3 Y's, 2 P's. You know what I mean? They're exactly the same. So we don't want to double count. So in this case, you would have to say, how many do we have in total? Did you figure that out already? 14? 14 total, right? So 14 total. So this would be 14 factorial divided by 4 factorial, 5 factorial, 3 factorial, 2 factorial. Right? You're dividing them all out because we don't care if you're moving all the blue ones around. We don't care about that. It's the same. If I looked at if I closed my eyes and you're like, okay, you move the blue ones, and then you open your eyes again, would you notice it being a different permutation? No, it'd be the same, right? So I know you're excited to go home, so I'll putter along here. How many arrangements if the same colors stay together? Wait a minute, Mr. Dixon, isn't there identicals? Yes. And now you're telling me they're staying together? Yes. So watch how this one works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Next time I'll do 100 balloons. No. Okay, 4 blue ones. 5 green ones, they stay together. 3 yellows, 2 purples. So what will we do within those groups? 4 factorial, 5 factorial, 3 factorial, 2 factorial, correct? Zoom in. Now you got to zoom out. 1, 2, 3, 4. So let's do this. 4 factorial, 5 factorial, 3 factorial, 2 factorial, and this is 4 factorial, right? This is zoom out right here. My radio's on, sorry. What's missing? What's missing? Don't we still have identicals? We don't want to count that. Okay, so we have to go, I'm going to use a different color, divided by, same as up here. You've got 4 blues, 5 greens, 3 yellows, 2. What's going to happen with all those factorials that are exactly the same? Cancel, cancel, cancel. So is it just 4 factorial, Mr. Dirksen? You bet. You bet. Hold on. I don't think you realize. Yeah. Question? That's fine. Like cross cross or cross like this? Yeah, it's fine. As long as you have 24 at the end, we're fine. Okay, hold on. Do you understand why this is? Because does it matter me taking this blue one, putting it over there, and then this blue one there? I can move all of these blue ones around, like it's still the same. Like it's just the one permutation. So that's why you're basically canceling out. So basically it's just these 4 groups being moved around that we're counting, right? It's like this one goes over here, this one goes over here. That would matter, but everything else within the group doesn't matter. So that's why this is the case, okay? I know you're excited to go home. Let's just move on, Mr. Erickson. What if you put a unique smiley face on every single balloon? No identicals anymore. There are no identicals, right? If every balloon has a unique smiley face, I treat them each as a let's say there's 14 people lined up, right? They're unique. So what would this be? 14 factorial, that's it. I don't have to divide out the 4 blue, the 5 green. I don't have to do that. Does that make sense? I'm trying to go back and forth to let you see, that how things work. Now, how many arrangements would not have all colors together? It would be 14 factorial minus, we're going to go up here where we figured out all of them being together, which is 4 factorial or 24. It's up to you. Please don't say this is 10 factorial. You can't do that. 14 minus 4, oh, 10 factorial. It's not. It's wrong. Don't do that, okay? Just figure out what this is. Figure out what that is. I don't have the key in front of me right now, so 1 second. It's a big number minus. Oh yeah, this is a really big number. See its scientific notation? So we're just going to leave it 8.71 times 10 to the 10. I would probably just ask you to do this, and the province would ask you to just do this. How would that be possible to figure out? Mississippi, I'll post the key. The key is actually, I think I already posted it. If not, it's going to come up. Yeah. The 4 comes from here. You could have used 24. Have a good weekend, guys.